This is our last video lesson, dividing radicals. So this is the last thing we're going to talk about before your test. So you should have 2 days to study. Hopefully you do study and you do really well. All right. So first thing I want to talk about is the steps. Okay. The first thing you want to do is we're going to break apart the radicand using the quotient rule. Okay. So when I break apart the square root of a over b, I get the square root of a over the square root of b. Okay? Then we're going to look for perfect squares and simplify them. We're going to divide or reduce the radical if possible, and then simplify any resulting radicals along with any coefficients. We're actually not going to be having any exponents in here. So this shouldn't be terribly difficult, okay? So first thing I want you to notice, hopefully you do notice, and maybe you want to take a second and write down the first 10 perfect squares so you can identify them. 1, 4, 9, 16, 25, 49. Oh, forgot 36. What the heck? 49, 64, 81, 100. All right. So those are the first 10 perfect squares. The roots I'll write underneath. If I were you, I would do the same thing. All right. You want to see, like, are these numbers, like when I break this apart, is it going to be a perfect square over a perfect square? Well, sure, because 49 is a perfect square and so is 100. The roots of the number is underneath, so it's simply 7 over 10. All right, if we had to reduce or simplify, we would do that. So I shouldn't call it reducing because it's not. All right, look at number 2. Is 8 one of my red numbers that it's a perfect square? And is 32? It's not. So what I would like you to do is kind of pretend that we're talking about 8 over 32. And I want you to get your calculators and simplify this in fraction form. All right. So, and sorry for you guys that don't have a calculator. I've been telling you all year that you need to get one, or you could have signed one out, but it's a moot point at this point. Anyway, so hopefully you do 8 ABC 32 or 8 divided by 2, 32. Math 1, enter, and you get this is 1/4. Okay, let's put this back in here. So we'll have the square root of 1 over 4 because this 8 over 32 is the same as 1/4. All right, and I can break it apart. The square root of 1 over the square root of 4. Go back to my list. 1's a perfect square, 4 is a perfect square. So that means this simplifies to 1 over 2. All right, if they're not perfect squares, read out the gate. Try to reduce the fraction and then simplify what you have after that. Take the square root of what you have after that. All right, let's look here. Now, this one's a little tricky because if you try to divide, it doesn't simplify. It's going to say 3 over 16. So you're like, what the heck? So let's break it apart. I have the square root of 3 over the square root of 16. Let's refresh our numbers. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. All right, and again, if I go too fast, you can always pause the video so that you can write down what I have. I'm going to write the roots next to the numbers in pink. Then I have a reference. Right, you do know that a perfect square has identical factors, right? 10 times 10 makes 100, 9 times 9 makes 81, 8 times 8 makes 64, and so on and so forth. All right, 3 is not a perfect square, but 16 is. So that means I'm going to leave the 3 in the radical, and I'm going to take the square root of 16, which is 4. That's the answer, guys. It doesn't get any smaller than that. All right. If you try to simplify number 4 with the fraction thing that I was talking about, you would get 1 over 7. 7 is not one of my perfect squares. And here's another thing. You cannot have a radical in the denominator. No radicals in denominator. Period. All right, if you leave a radical in denominator, it's just going to be incorrect right off the gate, right out the gate. Okay, so I know if I have this be a 7, I'm going to have the square root of 7 down here, and I can't. So let's break it apart. The square root of 7 over the square root of 49. Because 49 is on my list, right? The square root of 49 is 7. So I have root 7 over 7. They are not like terms. Radical 7 is not the same as 7. If you don't believe me, get your calculator and do square root of 7 and hit enter, and you're going to get a number that doesn't say 7. All right, so that's it. You're done. All right, so now, this is crazy, okay? Neither of these numbers in number 5 are perfect squares, so let's see if we can simplify the fraction. Right? So let's just pretend we have 10 over 45 and pretend right now that we don't have a radical. And if I simplify this, this gives me 2 over 9. Well, now I can rewrite it, the square root of 2 over the square root of 9. 9's a perfect square. My big thing is I can't have radicals in the denominator. I need this to be a perfect square. All right, so that gives me the square root of 2 over 3. Now there's no radical down here, and everything's all lovely. All right, so you guys are gonna love this one. Maybe not. 36 is a perfect square. There it is. All right, so what I'm going to do is I'm going to go ahead and take the square root of 36. That's 6. Again, those are not like terms, but I can simplify the square root of 12. Okay, so the square root of 12 breaks apart into the square root of 4 times the square root of 3. The square root of 4 is 2, so 2 root 3. That's the same as the square root of 12. So what I'm going to do is I'm going to replace this numerator here. So now I have 2 root 3 over 6. I can simplify 2 over 6. Okay, it's not going to be 3. It's going to be 1/3. The bigger number is in the denominator. So it's going to be 1 square root 3 over 3. That's my final answer. You do want to make sure you're simplifying the radical so that you have your answers totally simplified, okay? And hopefully you're pretty good at simplifying radicals after doing them the last couple days. All right, so if I try to, I can simplify. These are both like terms, so I can divide 3 into 96. That gives me the square root of 32. Now I need to simplify using the radical rules, right? We want to divide out our largest perfect square, so the biggest number that goes into 32, which is 16. 16 times 2 makes 32. So the square root of 16 is 4, so 4 root 2. Donezo. All right, now, this is gorgeous, right? We can divide the radicals here. 6 goes into 108 18 times. And I can simplify the square root of 18. Square root of 18 breaks apart into the square root of 9 times the square root of 2. Don't forget you had a 7 out front, so you're going to multiply that times the root. So the square root of 9 is 3. Bring down your 7. All right, so the last thing we have to do is, though, multiply. 7 times 3 gives me 21 root 2. Okay. All right, here's a funky thing again. So this is kind of crazy, and you have to just practice with it, you know. 45 is not a perfect square, neither is 5. I can't have this down here, but let's see if I simplify the fraction. 5 over, actually, I'm going to put it over here. I'm going to write it over here on the side. 5 over 45. If I simplify that in fraction form, that gives me 1/9. Well, 9 is a perfect square. So now I'm going to put it back in the radical. Square root of 5 over the square root of 9. Oh, why did I leave the 5 up there? What a weirdo. Sorry about that, guys. Beep, beep, beep. All right. So 5 over 45. 5 over 45 became 1/9. So I have 3 times radical 1 over radical 9. Well, the square root of 1 is 1, so I have 3 times 1 on the top, and the square root of 9 is 3. Well, 3 times 1 is 3. 3 over 3 is 1. What? That's weird. How did this become that? It's math, man. It's math. It's magic. All right, real quick. Yeah, I got a problem here. I cannot have radicals down here. So let's do quick like 15 over 27. And if that simplifies and it gives me a perfect square as a denominator, then I feel pretty good about that. So when I simplify that, that gives me 5/9. And I'm like, oh, 9. We already know 9's a perfect square. So let's rewrite this with these numbers. Okay, so I have 4√5 over 3√9. I'm not worried about the 5, okay? I am worried about the denominator. I cannot have radicals in the denominator. So 4 square root of 5 over 3 times 3, because 3 is the square root of 9. So this gives me 4 square root of 5 over 9. If I could simplify the 4 and 9, I would, but I cannot. No, I cannot. That is all I can do. All right, here we go. So, you can go ahead and divide here. See, if you take 48 and divide by 3, actually, you know what? What I just noticed is 2 goes into 10 5 times, 3 goes into 48 16 times. So now that's awesome because I no longer have a radical in the denominator. And 16 is a perfect square. So this is really 5 times 4, which is 20. All right, now, if you take 7, let's try this one. If I take 84 and divide by 7, I'm hoping it goes in right. It goes in 12 times, right? So I have, this becomes a 12. 84 over 7 is just 12. So I'm replacing this 84 with the 12. So 3√12 over 15, really just 15. Well, this is awesome because now I need to also simplify this. That's root 12 over 5. And I don't know if you recall from earlier on the top, the square root of 12 can be further simplified. This breaks apart into the square root of 4 times the square root of 3 all over 5. The square root of 4 is a perfect square, so that gives me 2√3 over 5. All right, I know this is a little funky, but just write down your perfect squares. Try and divide. See if you can get that denominator to be a perfect square, or if you can get it to disappear altogether by dividing, because the radicals are like terms. The coefficients are like terms. Okay? And if you're really struggling, there's math teachers to ask for help. You can also go on YouTube and see if you can find a better video that might help. At least this notes wasn't too long. Wait, before I call it a day, I want to make sure I'm not cutting everything short. Yep, that's it for today, guys. So make sure you show your sub your notes, and then you can get your assignment for the day. And I hope you guys have a great day. Bye!